Hey guys, Miss Leslie here. We are going to do part 2 of our function terminology in this video. So we went kind of long in the first video, so I figured I'd just stop recording and we'll finish it up in this video. So you get a two-part day. Sorry about it. At least you didn't have to sit through it in class. All right, here we go. Boop. Okay. So now I gotta scooch over. I gotta like move my head so like the banner thing for the video doesn't like cut my head off. Anyways, doesn't matter. We're getting into our video. So here we go. So now we're going to talk about 3 things that you may have heard in Algebra 2. You may have not heard it. They talk about it, but who knows, depending on which teacher, how in-depth they're going to go. So we get to talk about it now together. Okay, the first thing is end behavior, and this means exactly what it sounds like. What is the graph doing as it goes towards the ends of the graph, right? So end behavior is really the behavior of the function as x gets really, really big in the positive direction and really, really small in the negative direction. All right, so let's just write that. So it is the behavior of a function as x gets really big in the positive direction and really small in the negative direction. I swear I have really good handwriting when I'm not writing on this thing. I apologize. I know this is like disgusting to try and read. Like I said, I promise you I actually have really nice handwriting. Okay. So, like I said, this is really like the ends of your graph, right? What your graph is doing as it goes on forever in both directions. So in the positive direction and in the negative direction. All right. Now, if your value does actually approach something, we say that your function has what's called a limit. All right. So a limit is the value that your function approaches as it goes to infinity in both directions. All right. So limits, right? This is the value it's not your function, right? You don't own a function. The value a function, there we go, approaches as x goes to positive infinity and as x goes to negative infinity. Not all functions have a limit. I don't know if any of you guys have watched the movie Mean Girls or not. It's a really good movie with Lindsay Lohan before she went all cracked out. But anyways, there's a scene in the movie where she's doing like this mathletes club or whatever, and they're doing this like wicked problem, and all of a sudden Lindsay Lohan is like, the limit does not exist. The limit does not exist. That's what we're talking about. That's this limit. It just means that your graph doesn't actually approach anything as x gets really big or really small in the negative direction. All right, so if you've ever wondered what she was talking about, this is what she's talking about. All right, now limits have special notation. We call it limit notation. It looks very fancy. It is not. All right, so limit notation looks like this. So you see you have LIM, short for limit. And then underneath that, you have your variable. Generally, we're going to be using x. And then an arrow, which is saying like as x goes to, and then something. Generally, this is going to be for end behavior. This is going to be infinity. So that is limit notation. Now, the next thing, what we put inside the limit, that's your function. All right, so sometimes you'll see them actually like write the equation of the function. So like we could say our function is like 1 over x, or Sometimes they'll just put function notation. So sometimes they'll just put like f of x. And you don't always see these parentheses here. Sometimes you'll just see it like this, just simply written limit of f of x. That's really common. And then an equal sign. And this is where you would put whatever the limit of your function is. Now, infinity counts as a value. So as x gets really big, if it's going to infinity, you can put infinity, even though we know infinity is not an actual number value. But more than likely, it's probably going to be approaching some number. Most of our functions generally, like I say, they kind of approach a number, but sometimes they do just go to infinity, like quadratic functions. As x gets really big, it's just going to keep going up for forever. So you just put infinity, right? But it depends. All right, now you have n behavior as x goes to infinity. You also have x behavior as it goes to negative infinity, and that looks almost exactly the same. I'm going to write it right here since this is where I have the most room. So if you want to do negative infinity, you do the exact same thing, except instead of positive infinity, you put a negative infinity. And then you would just put whatever your function is. So you can either put f of x, or you can put the actual function itself right there. I don't have an example function right now. We can look at that in a sec because we do have an example if you look down at the bottom of the screen. So you can either put the actual function in place of f of x, or you can see it sometimes as just f of x if they're trying to be like generic. But that's limits. All right, so a limit is just whatever your graph approaches as x gets really big in the positive direction and really big in the negative direction. All right, last but not least, asymptotes. So in the last video, we referenced asymptotes because we had a rational function that we were trying to find the domain and range of, and rational functions are functions that have tons of asymptotes. You can have rational functions that have like 3 or 4 asymptotes in them. It can get pretty wild, and we are going to look at some pretty wild rational functions, but they get their own unit, which is next, unit dos, right? So I like unit 2 a lot, if you can't tell. But anyways, we're just going to give like a general idea / summary of what an asymptote is. All right, so basically, in the most brief words that I can use, an asymptote is an invisible line that your graph will never cross. That's what they are. All right, so we'll say an invisible line that a function will not cross. You shall not pass. Okay. Oh man, it is the weekend, y'all, and I am just not really focused all the way. It's okay. All my movie references, it's fine. Okay, so an invisible line that a function will not cross. Now I'm gonna actually put like a little asterisk next to that because there are some types of asymptotes that you may cross. We're going to look at some when we get into really detailed rational functions, but it only happens in very specific instances. It's not something that happens often. So for the purpose of this unit and for the purpose of right now, an asymptote is an invisible line that a function will not cross. It's going to approach it, but it's never going to cross it. Okay. Yeah, so those are our last 3 keywords. Now I just want to do one example problem that kind of looks at all 3 of these parts, and then we will be done with this video. So much shorter than the last one. Okay, let's scroll. I have like multiple touch screens I'm working with here. I'm super fancy. Okay, let's just zoom in a little bit there. Okay, here we go. Okay, so, oh, you can't see. Determine the end. Oh yeah, that's it. Okay, cool. All right, so find the location of any asymptotes and determine the end behavior of the function. Now, this function is super boring. This is actually one of our parent functions. So in class, we are going to talk about parent functions. You guys are going to get a whole sheet of parent functions. There's like 12, I think, that we're going to cover in this class, pretty detailed. A lot of those are going to get covered in this first unit. Some of them we save till later. All right, but this is a parent function, which just means it's a function that hasn't been transformed in any way. It's like the bare minimum of a function. And this is our rational function. All right, I've heard this called like the power function. I don't know. People make weird names up. I call these rational functions. This is a rational function. To me, if the x is on the bottom of a fraction, it's a rational function. All right, so this is just our parent function. All right, so what we're going to do is we are going to go ahead and we're going to graph this really quick. All right, now if you don't know what this looks like, you would go ahead and use your graphing calculator. If you do know what this looks like, kudos to you. I'm going to go ahead and graph it because I do know what it looks like. I do, you know, I have a fun life. All right, well, anyways, when you graph it, you're going to see it looks like it doesn't cross either of these two lines. It never actually touches either axis. All right, your graph is going to go like, ooh, let's do a different color. We have all these colors, Miss Leslie. Why are you just using black? It's going to go like this, and it's going to go something like this. You don't have to be the best artist. A general sketch is pretty good. Okay. So this is your function f of x equals 1 over x. All right, we actually have two asymptotes. All right, one comes from the fact that we can never divide by 0, right? So our first asymptote comes from that denominator, all right, where if x on the bottom, if that whole bottom ever equals 0, it's like the end of the world. I'm not really sure what happens when you divide by 0, but I remember learning in college it was a bad thing. So we know x cannot equal 0. Well, that's going to create that x equals 0 line, that vertical line. That's our first asymptote. So this one right here is the line x equals 0. That's one of our asymptotes. All right, our second one is going to come from that horizontal line that our graph looks like it's not going to cross. And remember, you can, if you're confused on what it's getting close to, you can always use the table in your calculator, because your y value will start getting really close to a certain number and then it won't ever actually like get to that number. And in this graph, it is just your y axis, right? So y, it's not what I meant. I put the slash in the wrong place. Oh my goodness. Okay, so y equals 0. So those are our two asymptotes, right? So y equals 0 is this horizontal line, whereas x equals 0 is the up and down line. So those are our two asymptotes. All right, so if we wanted to do domain and range, those would be the two values you would exclude. Everything else is fair game. Our graph is going to go in both directions on the x-axis, and it's going to go both directions on the y-axis. We're just skipping those 2 points. Okay, so let's look at our end behavior. All right, so this is, we want to take a look at what's happening as x is getting really big and as x is getting really small. So going in the positive direction, the negative direction. All right, let's do really big first. All right, so if we're looking at x as it goes off the graph in the positive x direction, what does it look like it's getting close to? Well, it looks like it's getting really close to that line y equals 0, right? It doesn't look like we're ever going to touch y equals 0, but it looks like we're getting really close to that line y equals 0. So the limit as x goes to positive infinity of our function f of x is positive. There's no such thing as positive 0. I was just about to say positive 0. It's just 0. Right? So as x gets really big, it's going to get closer and closer and closer and closer and closer to that 0 line, but it's never going to touch it. But that is our limit. So it's getting close to 0. All right, let's look at it in the negative x direction. So the green circle that I have. So, all right, here we go. We're looking at the green section. All right, so looking at x as it goes in the other direction off the graph. Well, it's doing the same thing, right? It's getting really close to that line y equals 0, but it's never going to cross it because it's an asymptote. All right, so it's getting really, really close to it, but it's never going to cross it. So we're going to say as x goes to negative infinity, our function is getting close to or approaching 0. Sorry if you don't like that I put a slash through my zeros. It's just, it makes sense so that you don't think it's an O, but like, why would it be an O in this situation? I don't know. You don't have to put a slash through your zeros. It's just, I think it looks kind of nice. That's what I'm thinking about right now as I'm doing these notes. Anyways, that is it. So that's end behavior, limits, and asymptotes. That finishes out our main terminology for functions. I hope you guys learned a lot. If you didn't learn anything, I'm sorry I wasted your time with this video, but hopefully you learned oodles and oodles and you feel more comfortable with functions now. I'm trying to find the stop recording button because I know you guys don't want to hear me talk anymore. Anyways, yeah, I hope you guys have fun doing your homework now. Okay, bye.